Okay, so let's talk about building something that sounds like it's straight out of science fiction. A machine that can practically read the human mind to spot devastating diseases like Alzheimer's years before anyone even knows something is wrong. I mean, that's a world-changing idea, right? But what's the difference between a vision like that and a failed startup? Well, let's get into it.
I mean, think about it. You might have the brilliant tech, you've got the A-team, you've got all the passion in the world. And yet, so many companies with all that, they just crash and burn. So what gives? It turns out they stumble one after another into a series of traps. Traps that are actually super common, but, and this is the important part, completely avoidable if you know what to look for.
And that's the absolute key takeaway here. It's not just about the technology, it's not about having the cleverest algorithm. Building something that actually works in the real world, well, that's all about strategy. It's about getting the realities of medicine, of data, and of business right from the very beginning.
All right, section 1, the world-changing idea. So let's walk through this. Imagine a founder with this incredible, amazing ambition to use something as simple as eye movements to diagnose brain disease. And the first pitch? Oh, it sounds fantastic. It's simple, it's powerful, it's straight to the point. But as we're about to see, it's also just wrong. So they walk into a neurologist's office and say, our tool diagnoses Alzheimer's. And right away, that's the first huge mistake. For the clinician, alarm bells are just blaring. Why? Well, think about it. A diagnosis for something like dementia isn't one single thing. It's a puzzle made of a ton of different pieces. Clinical exams, brain scans, the patient's history, cognitive tests, you name it. There's just no way a single tool can come in and replace all of that expertise.
Okay, section 2, the clinical reality check. So our founder, armed with this big idea, steps out of the quiet, controlled world of the lab and bam, they hit the real world. This is where the beautiful vision smacks right into the tough, messy, incredibly fast-paced reality of a neurology clinic. And let me tell you, the feedback they get is, well, it's a little humbling.
So, what's the fix? Well, it's actually a really smart pivot. You stop calling it a diagnostic tool. Instead, you reframe it as clinical decision support. See the difference? You're not replacing the doctor anymore, you're helping them. You're giving them solid, objective data to back up their own expert judgment. That simple change in language, it builds trust instantly. And, oh yeah, it also helps you sidestep a whole universe of regulatory nightmares. Big win.
All right, mistake number 2. This one is all about practicality. The founder, back in the lab, built this gorgeous system. It's perfect. It's pristine. It works flawlessly when a researcher has like a whole hour to spend with one person. But a real clinic? It's organized chaos. Doctors are sprinting. They've got maybe 10, 15 minutes max with the patient. Your tool has to fit into that world. It can't be the other way around.
And this is what that actually looks like in practice. This is the workflow that works. You've got a quick 1-minute calibration, a couple of tests that take a few minutes each, and boom, the report generates in seconds. The whole shebang? About 8 minutes. It's fast, it's efficient, and most importantly, it slides perfectly into that tight 15-minute patient slot. Now this is something a doctor can actually use.
And the last piece of this clinical puzzle is the report itself. I mean, engineers, they love their raw data, right? Give them all the complex graphs and statistics. But a doctor, they're on the front lines. They need to know what it means. So a report filled with jargon like velocity, profile, variance, distribution, that's just noise. It's useless. But a report that clearly states, look, the patient's time was 240 milliseconds. The norm is around 210. They're a bit slow. Now that is incredibly valuable. You've got to speak their language.
Okay, on to section 3, the builder's dilemma. So our founder has listened. They got the memo from the clinic. They go back to the drawing board to build this thing the right way. But just when they think they're in the clear, a whole new set of traps pops up. This is what we call the builder's dilemma, where you could make the wrong technical choice and just sink the entire project before it even starts.
And the first big temptation is, oh, it's a shiny one. Let's build our own custom hardware, a sleek, branded proprietary eye tracker. And let me tell you, that is a track. A huge one. Hardware development is just agonizingly slow and ridiculously expensive. The much, much smarter path? Build your amazing software to run on hardware that already exists and that people already trust. You'll get into clinics and start collecting that precious data years faster.
All right, now let's talk about data. And this might be the single most common, most critical underestimation in this entire field. Every founder knows they need data to train their algorithms, to prove their tech works. But almost every single one of them thinks they need way, way less than they actually do.
So where do they start? Usually with a number that's, frankly, kind of funny. 20 patients. Yeah, let's just get 20 people in here. Our AI is smart. It'll figure it out. But here's the thing anyone in clinical research knows. Humans are messy. Our biology, our behavior, it's all incredibly variable. It's noisy.
So, okay, they adjust. They double it. All right, fine. 40 patients. Surely that's got to be enough to find a signal, right? Nope, not even close. You're not even playing in the right ballpark yet. And this mistake is just so common because it feels kind of logical. But the reality of clinical neuroscience, it's just not that simple. And here is the reality check. To do even a bare minimum pilot study, you're looking at around 90 people. 90. If you want to publish actual, serious research, that number jumps to about 300. And if you want to create a truly strong, reliable biomarker that doctors can depend on, you need data from over 1,000 participants. 1,000! Understanding this too late, that's a project killer right there.
And the final trap for the builders, overbuilding. This is where you spend years and tons of money creating this gigantic, beautiful platform. It's got cloud dashboards, fancy mobile apps, the whole 9 yards, all before you've answered the most basic question. Is our core measurement even reliable? It's like building a massive skyscraper before you've even checked if the foundation is solid. You've got to get that part right first.
Section 4, pitching the real value. All right, so our founder has made it. They dodged the clinical mines. They navigated the technical traps. They've got a smart product, a solid strategy. But now comes the final boss, convincing investors to actually fund the thing. And that, well, that requires a completely different kind of storytelling.
And really, it all boils down to this, how you frame it. You pitch a fast clinical assessment tool, and an investor's eyes light up. They see dollar signs. They see a path to revenue, to clinics actually using this thing. But if you pitch a research experiment system, well, that sounds cool and scientifically important for sure. But to an investor, it sounds like a tiny academic market with no money in it. To get the check, you have to sell the clinical business story. And that clinical story has to be anchored in cold, hard economic reality. Because clinics care about the bottom line. Is it cheap? How long does it take to train my staff? Can my tech set this up in 2 minutes between patients? And here's the billion-dollar question. Can we get reimbursed for this? If you can't give a solid yes to these questions, your amazing technology is just going to sit on a shelf.
So, after all of this, all the mistakes, all the lessons learned, our founder finally sees it, the true path to success. It's not one giant leap of faith. No, it's a sequence. It's 4 deliberate, logical stages that take the risk out of the equation and build momentum step by step.
And here it is, the roadmap to actually making it. Stage 1, you nail down your measurement system, make it rock solid. Stage 2, you go get that pilot data set. Stage 3, you use that data to get research validation, get it published. And only then, after all that work with all that proof, do you go to stage 4, pushing for real clinical adoption. See how that works? Each stage is built on the success of the one before it.
And this is it. This is the #1 killer of companies in this space. They try to jump. They build their tool in stage 1, and then they try to leap all the way to stage 4, to selling it to clinics. They skip the hard work of collecting data and proving it works. And that jump, it almost never, ever works.
So let's circle back. Our founder now has the perfect roadmap. They know the traps to avoid, the product is smart, the strategy is sound. But the journey, well, it isn't over, not by a long shot. Because even when you do everything right, you're left with one final, massive question. How in the world do you find the hundreds or even thousands of patients you need to prove your idea actually works? And solving that puzzle, well, that's a whole other story.